In this video, we're going to discuss the heating mantle and the rheostat. So far, in your general chemistry classes, you would have run into maybe two other ways to heat samples up. The first one is the one on the left here. That is a Bunsen burner. A Bunsen burner has an open flame. The flame would shoot out up over the spout here, and it would be like a very sharp point of contact between heat and a sample. So if you want to heat a specific point of a sample up very, very hot, you would use a Bunsen burner. That's with an open flame. Now, we will almost never use Bunsen burners in the organic chemistry laboratory because organic chemicals are almost all flammable. You use that in your daily life. If you think about propane, gas tanks, or gasoline, those are organic compounds, and they burst into flames, and we use that to our advantage. But in the organic chemistry laboratory, we don't want our samples bursting into flames in our faces, and so we will never use a Bunsen burner in these classes. The second way, a slightly less sharp of a way to apply heat, is with a hot plate. And a hot plate is a lot like a stovetop. You put something on it, and through direct contact, the heat goes into the sample. Where the heat only goes into the sample where the sample is in direct contact with the hot plate itself. So I'm going with this analogy of being sharp to blunt. The Bunsen burner is the sharpest. It really sticks heat into a precise point on a sample. The hot plate helps to spread it out over a two-dimensional plane, so it's not like a one-dimensional poker hitting the sample with heat. This spreads the heat out into a two-dimensional plane. But the trouble with both the Bunsen burner and the hot plate is they don't spread the heat out a lot. They're kind of a sharp way to poke heat at something. And because of that, glassware can crack when you use it with Bunsen burners and hot plates. The places in the glassware that get really hot expand. The places that are not touching the heat don't expand. And then the expanded part doesn't fit together with the cold part anymore. And so the glass cracks. So although a hot plate does not have an open flame, and so you can often use a hot plate in an organic chemistry laboratory, unlike a Bunsen burner, the disadvantage is that your glassware could break, ruining all your sample and all your hard work, because it only heats up the part of your sample that's touching the hot plate itself. So those two heating methods you would have learned in a previous chemistry laboratory. You would have at least been exposed to in a previous chemistry laboratory. In organic chemistry, we're going to use a new way to heat samples, and that's a heating mantle. And that's on the right here. So if we're going from sharp to blunt, this is the bluntest way of applying heat. It diffuses the heat very evenly over a sample. And that's with a few reasons. Let's take a quick tour of this, just some features of this heating mantle before we talk about how it applies heat and how that heat is different from the heat that you would get from a Bunsen burner or a hot plate. One thing you'll notice at the bottom here is the sort of on and off button. This will get brighter or dimmer based on how much heat you're applying. We'll see that in this video. So that down at the bottom right tells you how much heat is getting through your sample. You have the plug, of course, that's where you put your plug in. You also have a place in the back that can hold a metal rod. So these standing rods you can use to keep things firm. You keep things from falling over by attaching them to these metal rods. And so you can stick a metal rod into this heating mantle to keep anything that you're heating up from falling over. And those are the different features of the heating mantle itself. What's really unique about the heating mantle is the cupped area. And you'll notice that in addition to the metal cupped area at the bottom, underneath it you have this cloth. That cloth is partly it's made of glass and partly it's made of plastic. It's fiberglass. And the fiberglass does not conduct heat very efficiently. So the real heat source is on the other side of that fiberglass. When the heat hits the fiberglass, it gets spread out. The fiberglass doesn't communicate the heat well, so it spreads out through the fiberglass And you get all of this diffused heat pointing in every which direction off of the fiberglass. And then that collects in the metal wires here to heat your sample up. That fiberglass cloth that spreads heat out and diffracts it in different directions so that everything is heated up evenly, that's what allows you to heat things in a heating mantle without the glass ever cracking. So when you heat something up in a heating mantle, your whole piece of glassware will heat up evenly, unlike with a Bunsen burner or a hot plate. And because it's heating up evenly, even if the glassware does expand, every piece of the glassware will expand. And so the glassware won't crack because all the atoms will still line up. So, to use this heating mantle, you'd of course plug your wire into it. Now you don't want to plug that heating mantle directly into an outlet. If you do that, it will just be on 100%, and that will often just fry your sample. You want to be able to control how much heat is getting to your sample. So you wouldn't plug the heating mantle, this wire from the heating mantle directly into an outlet. Instead, you would plug it into something called a rheostat, and that's what's on the left here. So you'd plug it into the rheostat. The rheostat acts like a sort of dimmer switch that allows you to adjust how much heat will get into your heating mantle. So this is your rheostat, and if you look at it from the top, you'll see there's a dial, and that dial tells you how much heat or electricity you're allowing to get through. So 0, you're not allowing any electricity to get through. 100, you're allowing a lot of electricity to get through. That's the amount of electricity you would get if you just plugged the heating mantle directly into an outlet. So this is a dimmer switch. It tells you how much heat you can get through. And the way it works is there's just a bunch of wires coiled up around inside of it. And the less heat you want to get through, the more wires the rheostat will send the electricity through. And as the electricity travels through the wires, it gets weaker and weaker and weaker. And so the more wires, by adjusting how many wires you send the electricity through, you can adjust how much electricity is getting to your heating mantle, and therefore how hot your heating mantle will get. The other part of this is you have that on and off switch in the top left, and that determines how much electricity this is even going to let into those wires, the sort of power of the flow of electricity. So you have an option for 140 volts on the top in this one and 120 volts on the bottom. If you compare a rush of electricity with maybe a river, 140 volts would be like a rushing rapid river with white water, and 120 volts below would be like a calmer type of river. So we're going to use 120 volts for our heating mantles in class. So once you have your heating mantle plugged into the rheostat, you'll plug the rheostat in to the outlet. So remember, never plug the heating mantle into the outlet, plug it into the rheostat, and then put the rheostat into the outlet. And you can see those two wires there, the one that's moving from the heating mantle to the rheostat, the other that goes from the rheostat into the outlet. You'd put it on 120 volts, and now watch the light, the on and off light on the heating mantle as we adjust the dimmer switch on the rheostat. So there's that on and off light. Watch it get brighter or dimmer as we send more or less electricity through the rheostat. And there it is, getting brighter, brighter, brighter. Oh my gosh, it's blindingly bright. Exactly. And then as we dim it down, it'll get dimmer. And so based on how bright that light is, based on the position of the dimmer switch of the rheostat, you can tell how much you're heating up your sample. Oftentimes, if you heat a sample up too quickly, in addition, your experiment will get foiled. It'll mess up your experiment. You'll provide too much heat and you'll get weird side reactions happening, or things will boil together so you wouldn't separate them. And so in this video, we've introduced the heating mantle. It's sort of a blunt way of applying fuzzy heat, applying heat evenly across an entire piece of glassware so the glassware doesn't break, and then plugging the heating mantle into a rheostat to be able to control how much heat you're applying. to the sample you place in the heating mantle.